on the board that has to do with RL circuits, and we have been asked to find the resonance frequency, and the maximum current at which the resonance occurs. So we're going to do that. Right away, we need to draw an RL circuit, okay? And that goes this way. We have our inductor, resistor, inductor, and then finally we have our capacitor, and then all connected in series. All connected in series, and that will give us this, as you can see. This is the resistor, right? And this is the inductor measured in Henry, and this is the capacitor measured in farad. And resistance is measured in ohms, so we take note of this. Just the normal thing we know, right? So if we take care of this potential drop at this point, and then we have this, we have also potential drop at this point, we have all that, and then potential drop at this point, potential drop at this point as well. That's what we're going to take care of. But our concern is not about all these potential differences. No, what we need to do here is to find the resonance frequency and the maximum current. So how do we do that? It's very simple. So to find the resonance frequency, we have F0 is equal to 1 all over 2 pi square root LC, where the various letters remain the same, retain their usual meanings. L stands for the inductor, and then C stands for the capacitance, right? R stands for the resistance offered in the circuit. But we must understand, in an RL circuit, resonance F0 occurs when the impedance is equal to the resistance in the circuit. So let's go. What do we do? F0 is equal to 1 all over 2, bracket close. We have 3.142, bracket close once again, and then we have square roots of the inductance is given as 3 millihenry. Inductance is given as 3 millihenry. Capacitance is given as 0.05 microfarad, and then the resistance is given as 5 ohms. Look at it. The resistance of the circuit is given as 5 ohms. So we take care of that one by one. So for inductance, we have a 3 millihenry, which will be converted as 0.003, bracket close. We open again. Then for the capacitance, we have 0.5 microfarad, and then that should be 5 times 10 raised to the power of minus 8 microfarad, right? By the time we simplify this, by the time we clear this simple simplification, we have that the F0, that is resonance frequency, is given as 13 kilohertz. First up. So we have found the resonance frequency. That's what it means. We have found the resonance frequency by applying this formula, substituting wisely and simplifying. Then we arrive at F0, which is the resonance, equal to 13 kilohertz. Now the next thing we need to find is the maximum current. We need to find the maximum current at which, or the point at which the resonance occurs. So that's the next thing. And to find the maximum current, I mass, okay, is going to be peak voltage IV0 all over resistance. And remember what I said before, that when resonance occur, or for resonance to occur, the impedance of the circuit must be equal to the resistance of the circuit. So that's what it means. And then the next thing we need to do is to substitute the peak value of the voltage, the amplitude is giving us 2 volts. Okay? So we do that. 2 all over the value of the resistance, which is 5 ohms, and we substitute once again. So what do we do? Very simple. Okay? 2 cancel itself. 1, 2 divide 5 is going to, okay, we don't need to go that far. So if we divide, it becomes I mass, okay, I mass is equal to 5 goes against 2, cannot, you put point and then put 0 here, it becomes 20. 5 divided 20 is going to give us 4, and that is 0.4 amps, right? This is the maximum current at which resonance F0 or resonant frequency occurred. That's it. So it has been calculated, it's been solved. We don't have any problem with this. This is one of the simplest questions you'll be asked. So each time you have something like this, don't be afraid. Just apply the suitable formula and then substitute wisely, just like we did at this point, and then resolve to get this. We went on again to apply the peak voltage, which is 2 volts over the resistance offered in the circuit, and we have the maximum current at 0.4 amps. All right. Thank you. Once again, thank you for your patience and for watching up to this moment. Don't forget to subscribe, give some thumbs up, put on the bell button for constant notification, share with your students, networks, and friends. Belong to this family of great learners. Belong to this family of great teachers. My returning subscribers, thumbs up. My new subscribers, thumbs up. I am signing out.